There are different ways to secure APIs, both at infrastructure level and at application level. Often different methods are combined. We're focusing on application level methods in this course. What you're looking at is a diagram of where your APIs might live these days and how applications interact with them. Typically, APIs are public because modern devices like phones need to be able to access them, or web apps that run in the browser, like Angular apps, need to access them. Next to that, there's still server-to-server access possible as well, of course. When clients access our API, we want to know who the user or app is that accesses the API, and we want to check whether that user or app should get access. A very rudimentary way of doing this is by sending over the username and password on each request. But that is not such a good idea. First of all, you have to check that username password on each request to get user-related info. That's quite slow. But more importantly, this is a huge attack vector. If the connection isn't encrypted, a packet sniffer is all that's required to get a hold of your username and password. Moreover, seeing we're all human, chances are that we are reusing a password that would give an attacker access to a lot more than just his API. Using tokens is a better idea. Instead of sending over username and password combinations on each call to the API, we're going to send over tokens on each request. These tokens represent consent. For example, consent granted by the user to the client app to access the API. That token is then passed on each request to the API and gets validated at that level. That's already a lot better. We're no longer sending the username and password over on each request. We're only sending it once, get a token in return, and on requests after that we send that token to the API. Also, this approach will work for almost all modern application types. OAuth and OpenID Connect, which you may have heard of before, are protocols related to token-based security. We'll shortly cover those at the end of the module. What we're going to do now is implement our own form of token-based security.